Hi there. Now we'll be covering the review of our manual regarding the SP or spontaneous potential topic. In this chapter, we'll be covering the applications of SP, logging conditions, how that SP is generated. Well, here are the causes, the membrane potential, liquid junction. We'll move then to the baseline SP response in shale. There will be something called the resistivity shale baseline method, and at the end a really interesting topic about invasion profiles. So what is SP? What is spontaneous potential? I'd like to describe it with this image. It is basically a voltage that we will be measuring between our wireline logging tool, a resistivity tool, it could be an induction or lateral log, and another electrode that we're going to place in surface. This electrode in surface is just literally a cable that comes out from the wireline logging unit, and you just put it in the ground. You can dig a small hole, put the electrode, you fill that hole with drilling mud, and that's it. The voltage that you will be measuring will be between that electrode and the other electrode that is connected to your induction tool or your lateral log tool. So you can have an idea that it is like a really small voltage. So, but why running an SP? What is the purpose? Its applications. Well, you can use it to estimate the volume of shale. You can have an estimation of water resistivity. And it can also be used for well-to-well correlation. Although we would prefer a gamma ray to do that well correlation, but we'll cover that later. I just wanted to mention that the resistivity of the mud filtrate, you can get it in location performing a test. There is a device where you just put the drilling mud into this device and you turn it on, and it will give you the values of resistivity. So this value, you will get it in location easily. Regarding the logging conditions, I'll just add that this is a really small voltage, so there will be many factors affecting those readings. So how is created, how that voltage is generated? The very first and most important source are electrochemical processes. Within those electrochemical processes, you will be hearing the membrane potential and the liquid junction potential. Let's see what is that. So membrane potential, there's a cool image for that. So you have a permeable sandstone, you have water saturated shale. When there is a difference in salinity, ions, stars, they start to move from this area to this area. So in this membrane, that small potential is created. So that is membrane potential. And the liquid junction refers to the fact that during invasion, the mud filtrate enters there, and there is also an ion exchange between the different fluids that are now getting in contact. Let's remember that when we say invasion, it is the process where the drilling fluids enter into the formation, and now they're mixing. Electrocinetic processes, well, that is the cinetic part of that event, also creates small potential. But the greater contributor are the electrochemical processes. When we're talking about the physics of the measurement, I just want to say that again. It is like a really small voltage, so things like welding operations around could give you erratic readings. Cathodic protection, storms. If the wire line, if there's a leakage, that current will also affect your SP readings. Magnetism of the measuring wheel or the wire line drum. If you are familiar with what a measuring wheel is, this is the device that is used for measuring depth and tension in wireline units. So keep in mind that might be an issue. Now this is good. This is interesting. The baseline response in shale. So let's look at this. And this track, well, this is a track, big thing here. And this track, the red curve is the SP. What I want you to focus on this is that while we are in shale, imagine this formation, all this is shale, it will be giving you like the same reading, and then there is a deflection of the SP curve. In this case, this is a sandstone. Let's say it's a sandstone. When you're back into shale, it will give you the same reading as before. So the point is, at this moment, that a deflection occurred and it moved to the left. So why that happened? We'll be covering that. If you compare the response of the resistivity tools, something similar happened. Your resistivity curve were stacked and a deflection also occurred. So why that is happening? Well, the reason behind that is related to the contrast between the resistivity of the mud filtrate and your formation water resistivity. So if the resistivity of the mud filtrate is greater than the resistivity of the formation water, you will have a negative SP deflection. It will be positive on the contrary scenario. Now, something similar happened with your resistivity curves. Check this out. In this case, this is a resistivity tool. You're having the same reading on shale, then a deflection occurs in your resistivity curves, and then you're reading the same thing on shale. What I want you to see in this scenario is, or to find, is the resistivity shale baseline, and now watch the deep curve resistivity. In formation containing hydrocarbons, your dip will give you great values or higher values of resistivities. And in formations where there is no hydrocarbons, where it is full of water, it will give you low values of resistivities. There is like a general scenario. Now, on this area we're comparing the SP deflection with the resistivity curve responses, and I want to talk about this. Resistive invasion. What do we mean by a resistive invasion? This is what we mean. When the resistivity of the mud filtrate is greater than the formation water resistivity, that is referred as a resistive invasion. And they usually create a resistive profile. A resistive profile is when your shallow resistivity is greater than your deep resistivity. This is the case. A conductive invasion is the opposite. You can check this one. Examples of conductive invasion profiles in water saturated formation. This is important. At the left, the lack of SP deflection indicates that the resistivity of the mud filtrate is pretty much the same as the resistivity or water formation, or your shallow resistivity is pretty much, therefore the shallow resistivity is almost the same as your deep resistivity. But in this case, you have a positive SP deflection into the right, and this indicates that the resistivity of the mud filtrate is smaller than the resistivity of your water formation. So you have this response. We can go through all this. I just want to add to finish with the mixing and displacement as causes of invasion profile. Keep in mind these two keywords, mixing and displacement. When we talk about the mixing of water-based mud filtrate and original water in pore of the flush zone, this mixing occurs in both water-saturated and hydrocarbon-bearing formation. Now let's talk about mixing and displacement as causes of invasion profiles. Invasion profiles observed on resistivity logs are the result of two processes. So keep in mind mixing and displacement. Those are keywords here. The mixing of water-based mud filtrate and original water in pore of the flush zone. The mixing occurs in both water-saturated and hydrocarbon-bearing formation, and the displacement of movable hydrocarbons by mud filtrate in the pores of the flush zone. Invasion profiles in water-saturated formations are easy to interpret because they develop in response to mixing only. In a hydrocarbon-bearing formation, the interpretation might not be so simple. Mixing and displacement both occur in formation where hydrocarbon is present, so it's not that easy to interpret. And here we have a key comment. I would like you to check it later on. And we're finished with this graph. This is basically, let's read it. This is a progressive sequence of conductive invasion. A is a curve response prior invasion, so everything is written the same. Invasion hasn't occurred yet. B, curve response at onset of conductive invasion. This is a conductive invasion, so you start seeing like your shallow resistivity. This is smaller than your deep, and as invasion continues, you get this one. There's a more separation between this curve. So I hope you can get familiar with the invasion profiles, and thanks for watching.